Because its heat, its picante, is very...
It's the motherfucking Eagle Double G. Snoop Dogg.
My energy for communicating science derives from the research that I do. The research, for me, is thrilling. The press reports the results of research, which for some projects can take many, many years. So if you want to become a scientist, you have to learn to love the questions just as much as the answer, because in fact, in some cases, you don't even get to an answer. You find out you're navigating the wrong path. So the people who say, oh, graduate school is a pay, I can't, that is science. What you're doing as a graduate student is becoming a research scientist, and that's what you do. You work long hours, you're in the lab, you occasionally forego personal hygiene. You know, this is what that is, okay? I bet you Darwin and Newton did not smell very good, all right, is my guess, okay? Newton, while he is discovering calculus, all right, he's probably not saying, oh, I need a shower about now. No, he's pretty focused doing what he's doing, all right? And so that's where I derive my energy to share the passion. Now, I would do so no matter what. But there's a more important reason for doing it. And that is most pure research in the sciences that goes on in America today, that's not product-driven, goes on at universities, and the source of those monies are from public-based, tax-based funding agencies. So, collectively, we pay taxes to the country's portfolio of spending, some of which funds the science that's conducted by scientists. As a result, the science that's done, the scientist that conducts the research, is obligated to the public to share with them the fruits of their research. The public paid for it. And I submit to you that there was an era before that was taken seriously. There's an era where the scientist in the lab would say, the press is beneath me, they'll probably get my story wrong, I don't want to have anything to do with them, leave me alone. That happened only to the peril of the funding stream that went into those labs. And the first person to realize this in a big way was, in fact, Carl Sagan. Because what happened was, he would start bringing science to the public. He did it sort of first and best. And colleagues said, what, you're on the Tonight Show? You're a scientist, and you'd stoop to go on the Tonight? And he was criticized for this, criticized. Meanwhile, the scientific community saw their budgets rise. And so in astrophysics, we learned earlier than in other fields the value, the general value of bringing the fruits of our research to the public. And I can tell you that I don't know if I'm biased, probably I am, but maybe a little bit is not. I think Hubble images are pretty cool. I think these pictures I showed you tonight are kind of awesome. I think all of us, at some point, we look up and wonder what our place is in this universe. And a small fraction of the total population gets to actually call that their career. So at no time do I take it for granted that it is not only a privilege to study the universe, it's an honor to do so with the sanction of those who are taxpayers and who even come out and hear a lecture that I give. Thank you all again. Seattle. As an astrophysicist, we've seen throughout time the hubris that comes with any discovery that gets made, or the hubris that prevents the acceptance of a discovery that might demote your sense of self from whatever you previously imagined it to be. Among them is, where is Earth? Is it the center of all things? No, it's not even a significant planet in orbit around an ordinary star in the corner of a ordinary galaxy, one of 100 billion galaxies in the universe. And so here we are saying, let's search for life in the universe, intelligent life like us. Well, who are we to say that we're intelligent? I mean, I pose that not as a joke question, but as a very serious question. We define ourselves to be intelligent in ways that no other creature can rival. Okay, now what do we credit that intelligence to? So you look at the genome, and let's take the chimp. I guess that's a really close relative of ours. And we have, what is it, high 90s% identical, indistinguishable DNA. And the chimp does not build the Hubble telescope, and the chimp does not compose symphonies. So we must then declare that everything we say about us that is intelligent is found in that 1.5% difference in DNA. Is that a fair statement to make? Okay. Let me invert that question. If the genetic difference between humans and chimps is that small, maybe the difference in our intelligence is also that small. Maybe the difference between stacking boxes and reaching a banana, putting up an umbrella when it rains, whatever are these rudimentary things a chimp does that the primatologists roll them forward and boast about, which of course our toddlers can do, maybe the difference between that and the Hubble telescope is as small as that difference in DNA. Because I pose the question, suppose there was another life form on Earth or elsewhere, that in that same sort of vector, that 1.5% difference we are to chimps, suppose they were 1.5% different from us. They would then roll the smartest of us in front of their humatologists and say, Hawking, there's Hawking, oh, this one is slightly smarter than the rest of them because he can do astrophysics calculations in his head. Like little Timmy over here. Yeah. So I wonder if we're just blithering idiots in the presence of even a trivially smarter species than us. So therefore, who are we to even assert that, number one, we are intelligent and we're looking for others at least as intelligent as us out there to talk to? By the way, is there any other species on Earth that we can talk to? Can we have a conversation with a chimp? That has nearly identical DNA, and I don't think we can actually say, hey, what movie do you want to see tonight? But you don't have that conversation with a chimp. Yet somehow we want to believe that an alien on another planet that's not even based on DNA, and even if it is, it's not nothing like us, that we could communicate with it.
Yeah.
I'm screaming at you, I'm sorry.
I find it hard to argue against that possibility.
Meaning?
Meaning, you look at our computing power today, and you say, I have the power to program a world inside of a computer. Well, imagine in the future where you have even more power than that, and you can create characters that have, for example, free will, or their own perception of free will. So this is a world, and I program in the laws that govern that world. That world will have its own laws of physics and chemistry and biology. Now, you're a character in that world, and you think you have free will, and you say, I want to invent a computer. So you do. Hey, I want to create a world in my computer. And then that world creates a world in its computer. And then you have simulations all the way down. So now you lay out all these universes and throw a dart. Which of these universes are you most likely to hit? The original one that started it, or the countless simulations, the daughter simulations that unfolded thereafter? You're going to hit one of the simulations. So statistically, based on that argument, which first appeared by a philosopher from Oxford named Nick Bostrom back in the 1990s, right when computers were becoming real enough to think this through. It's hard to argue against the possibility that all of us are not just the creation of some kid in a parent's basement programming up a world for their own entertainment. And then every time something weird happens in the world, some disruptive leader takes charge. And I wonder if that programmer just got bored and had to stir the pot. So they throw somebody in there just for their own entertainment. For me, that's some of the best evidence that we live in a simulation. Because this happens every time there's peace and tranquility in the world.
I don't want the religious person in the lab telling me that God is responsible for what it is they cannot discover. Because look at the hubris of that. You're in the lab and you say, I don't know how this works. And not only that, no one alive on earth knows how this works. And not only that, no one who will ever be born will know how this works. That's kind of audacious when you think about it. And then you put it down and go on to the next problem. If this problem is a cure for Alzheimer's or cancer or whatever else, I don't want them in the science classroom. And so the issue is simply about progress and discovery. And in my recent forays into Washington, well, I've been closer to a community of Republicans than I have ever been in my life, because I grew up in New York City. And in New York City, I think that person is Republican back there. You see? No, not that one, the one behind that person. Yeah, that's a Republican. There's another one. That's in New York. So you grow up this way, and I get sort of baptized into a Republican administration. I had 2 consecutive appointments in the Bush administration, one on aerospace, on the aerospace industry, and one on space exploration, NASA's future, basically. And I realized something, spending that much time in the community of powerful Republicans, that Republicans, above all else, do not want to die poor. So, there's a limit to how far this will go. And I bet most people in this room, even those assembled at this table, were highly concerned about the Dover trial, wondering how that would turn. And I looked at that and I said, I'm not worried, because it's a Republican judge. And in the end, if you put people who are not making discoveries in the science classroom, that is the end of the foundation of your future economy. And so I had a little more confidence than others did because of this sensitivity to the money aspect of it. But we all know tomorrow's economies will be founded on innovations in science and technology, and of course that gets cut short if we lose our civilization, as what happened in Islam in 1100. And the last thought I'll leave you with, which concerns me greatly, if you do the math, okay? You look at all the Nobel Prize winners there ever were, some even in this room, and ask how many were Muslim. And it's like 1, maybe 2, okay? I think a second one was in economics. And the one we referred to was described earlier, the co-winner of the Nobel Prize with Professor Weinberg, Abdus Salam. And he's not Middle Eastern Muslim, he's Pakistani Muslim. Okay? Now, how many Nobel Prizes are won by Jews? It's like a fourth of the Nobel Prizes. Okay? Some high fraction of the total. And then you look, how many Muslims are there in the world? It's like 1 billion Muslims. How many Jews? 15 million tops. Okay? So you ratio these numbers. Had Islam not collapsed in its intellectual standing in the year 1100, and you just do the ratios, they would have every single Nobel Prize today. So the fact that it's not only just a few, it's near zero, is deeply worrying. I'm concerned about what brilliance may have expressed itself and did not in that community over the past 1,000 years. People say, well, have you found life yet? No. Well, that's like going to the ocean. This has been said before, taking a cup of water, scooping up and saying, there are no whales in the ocean, Here's my data, You need a slightly bigger sample. Sir Isaac Newton. Now, I don't know what you know of Isaac Newton, but everything I've read of his tells me that there's no greater genius to ever walk the surface of this earth. I don't know if you've ever felt that about anybody. I didn't feel that about anybody. You just read what this man wrote, okay? Line by line by line. This guy was plugged into the machinery of the universe. I think he's unimpeachably brilliant. Unimpeachably brilliant. And let me read again what we heard from Mike Shermer earlier. In Isaac Newton's writings, by the way, in his Principia, here's the page 1, page 0 of Principia, in it, he discovers the laws of motion, F equals ma, discovers the laws of gravity, it's all there. And he did this all before he turned 26. And in this, when he talks about motion, there's no reference to God. When he talks about his two-body force that he deduced, this universal law of gravitation, there's no mention of God. It's just not anywhere there because he understood it. He was on top of it. He was there. Even though the understanding of the motions of the planets before he came along was given unto God because nobody understood it, or nobody understood well enough to really believe that they had a full predictive handle on it in the way the universal law of gravitation supplied. And so what you have is Isaac Newton abandoning reference to God until he realizes that if all you do is calculate the two-body problem, here we have like the moon and Earth. Yes, he's got that calculated. Now you have the sun and the Earth. You got that. But wait a minute, now the Earth and the moon go around the sun, and sometimes we're close to Mars and sometimes we're not. And when it comes near Mars, there's a tug that's stronger there than in any other part in the orbit. And then it comes over here, and then Jupiter tugs. And it's all these mini tugs. And so he's got to do this two-body problem for Earth, the moon, Earth and the sun, Earth, moon, and Mars, Earth, moon, Mars, and Jupiter, and it becomes a rapidly complex problem. And he realizes that, in fact, applying this simple sort of approach to calculating the stability of the solar system, he finds he can't stabilize the solar system. He can't account for how we have stayed this way for as long as what was possibly necessary from the beginning of the universe. And so what does he say? He's at his limits. He's at his limits. And so you read but God is nowhere until you get to the general Sholem. And then he says the 6 primary planets. Back then there were 6 planets, okay? Now there's 8, in case you haven't been keeping track. Even if you thought there were 9, there are now 8. The 6 primary planets are revolved about the sun in circles concentric with the sun, and with motions directed towards the same parts and almost in the same plane. He's got the whole picture now, and he's trying to sort of account for that. But he can't just simply doing two-body calculations, certainly not without a computer or without a new kind of mathematics. He says, but is it not to be conceived that mere mechanical causes could give birth to so many regular motions? This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. This is Isaac Newton invoking intelligent design at the limits of his knowledge. And I want to put on the table the fact that you have school systems wanting to put intelligent design into the classroom, but you also have the most brilliant people who ever walked this earth doing the same thing. And so it's a deeper challenge than simply educating the public. It's deeper than, as you know, by the books written by our scientific colleagues that do take these deeply resonant and charitable positions towards their religious beliefs. Maybe the real question here, let me back up for a moment. You know, we've all seen the data. 40%, there's 90 whatever percent of the West or the American public believes in a personal God that responds to their prayers. And then you ask, well, what is that percentage for scientists? Averaged over disciplines, it's about 40%. And then you say, how about the elite scientists, members of the National Academy of Sciences? An article on those data recently in Nature, it said 85% of the National Academy reject a personal God. And then they compare it to 90% of the public. You know, that's not the story there. They missed the story. What that article should have said is, how come this number isn't 0? That's the story. Okay? So my esteemed colleague here, Professor Krauss here says all we have to do is make a scientifically literate public. Well, when you do, how can they do better than the scientists themselves in their percentages of who is religious and who isn't? That's kind of unrealistic, I think. So there's something else going on that nobody seems to be talking about. That as you become more scientific, yes, the religiosity drops off, but it asymptotes. It asymptotes not at 0. It asymptotes at some other level, so they should be the subject of everybody's investigation, not the public. I'm telling you. So it's not 85% reject, it's at 15% of the most brilliant minds the nation has accepts it. And that's something that we can't just sweep under the rug.
You brought up Carl Sagan. What was your relationship with him? How'd you get to know him?
It wasn't, I think the press occasionally overstates what the relationship was. I met him when I was 17, just an anonymous high school kid. But what was remarkable about that was that he was already famous, though he had not yet done Cosmos. But he was already famous. He had been on Johnny Carson, The Tonight Show, multiple times, cover stories in Parade magazine. He was already well known, and I'd applied to Cornell where he was on the faculty, and unknown to me, the admissions office sent my application to him to get his comment and reaction. My application was dripping with the universe at the time, because I'd known since age 9 that this is what I wanted to do. He then sent me a personal letter inviting me to tour the campus and visit the lab so that I can make an informed decision of where I would attend. And so, yeah, I said yes. So I got on the bus, went from New York City up to Ithaca, New York. This was in December, in the winter. It was cold, and he indeed met me outside the building, took me to the lab, showed me the lab, reached behind him. I never forget this. Didn't even have to look. Grabbed a book off the shelf. It was one of his books, and signed it to me. I just thought, wow, that's badass. You don't even have to look, and wherever your hand lands, that's a book that you've written. And I still have that book. It was his book, The Cosmic Connection, and it says, "To Neil, future astronomer, Carl." And so then at the end of the day, he drives me back to the bus station. It begins to snow, not an uncommon thing in Ithaca, New York, I would later learn. And then he says, here's my home phone. If the bus can't get through, just call. You can spend the night with my family. And I'm thinking, I'm just like nobody from nowhere. And I remember distinctly thinking, if I'm ever remotely as famous as Carl Sagan, then I will have a duty and obligation to treat students with this level of kindness and generosity that he had exhibited with me. The Pope came out just a few news cycles ago saying what I thought were quite forward-thinking things about the role of science and discovery and the role of Catholicism relative to it. I think a lot of that had already existed in some way in Catholic doctrine, but the press made a very big deal of this. And
yes.
Did you have a reaction at the time?
Well, I think they made a bigger deal than necessary. I mean, Pope John Paul II said exactly the same thing.
Yeah.
And Benedict was not quite so vocal about it, but he didn't.
So they're there in some way.
They have no problem with evolution, and even back to Pius XII actually didn't either. But
because what we did, I was on a panel for the I was on a panel for the National Academy of Sciences to create a committee, to create a document titled Evolution versus Creationism. And it was a document for educators, resources. Here's how you teach it. Here's how you can show where creationism, religious creationism fails and how biological evolution succeeds. We made great efforts to create an appendix in the back that listed every single religious organization that was just fine with evolution. And there's like a council of bishops, or there's some organizations out there. So I want to pose a question back to you. That exercise of making this document is not telling people to not be religious. It's saying, here's evolution and it is objectively true, fold it into your religion or not, but this is all we're trying to tell you to do. Whereas other things you've done professionally, God Delusion and others, are arguing against religion entirely. Whereas our document just said, here are religious organizations, they're with us on this.
Yeah. That's a very important thing to do, because an enormous number of people actually...
They're influential.
And yes, but lots of people think that that in order to believe in evolution you've got to give up your religion. And their pastors, their priests, bear responsibility for that, and so it is a very important message to get out there. Sometimes I feel a little bit unsatisfied by that. I think that there is something deeply unscientific about religion, and
There's something deeply unscientific about Van Gogh's Starry Night.
yeah, no,
But I don't.
that's yes, that's different. That doesn't.
Well, that's why that sentence doesn't come out of my mouth.
The thing that's deeply unscientific about religion is that it's no, all right. Let's not say unscientific. It is a scientific theory that there is a designer of the universe. It's not something outside science. It affects your scientific view of the universe, if you think that there is. And having said that, it is important to disabuse people of the illusion that you've got to give up your religion if you take up evolution. That, however, has a paradoxical upside for me. If people have been told by their pastors that if you accept evolution, you've got to give up your religion, we can definitely prove evolution is true. I want them to give up their religion, and so if I can use evolution to get in there as a wedge and say, all your life you've been told that the moment you accept evolution, your religion is down the drain. I want that to happen. And so
You say that almost diabolically. Yes, I want that down.
But I know I'm in a minority there.
Sure.
And I know
because that's that's an extreme social posture to take.
It sounds
Yeah.
it, but I think it's highly reasonable.
Well, it happened to you.
Yes.
You converted, if we can call it
Yes.
that, after you learned
Yes.
Darwin.
So you see the paradox I'm raising?
Yes, I do.
That if people like you and Eugenie Scott manage to convince people that there's absolutely no incompatibility between, then I've lost my secret weapon, so to speak.
Okay, I didn't say there was no that. Okay, let me just clarify
Okay.
anything that I would have ever said. I never said religion and science are compatible, and that's a very common question that I'm sure I get all the time. Are they compatible? All I ever say is, if your religion is making testable claims about the physical world, be ready for the methods and tools of science to show that it's false. If you're not ready for that, then pick another religion or, move to an island. But if you're going to make testable claims, we're going to be all up in those claims. And the history of that exercise is one where science wins every time.
Every single time.
Every single time. If you look at the chemical ingredients of life itself, you remember from biology class, we're mostly water. And good old water is H2O. 2 hydrogens, 1 oxygen. And if you could look at the sort of the element budget of life, hydrogen is number 1, as expressed in the water molecule. The number 2 in the human body is oxygen, turns out. Number 3 in the human body is carbon. 4 is nitrogen. 5, you find on all lists, is other. Okay, now if you go to the universe, that's the O on the periodic table. You didn't know that? That's not for oxygen, it's for other. So you go into the universe, number 1 ingredient in the universe is hydrogen. That was true in life. Number 2 ingredient in the universe is helium. We don't have that one.
It doesn't like anybody.
No, how come? Well, because helium is chemically inert. You can't do anything with it even if you wanted. Or you can inhale it, okay? And sound like Mickey Mouse, yes. Next in the universe is oxygen. Next, carbon. Next, other. Thank you, in the 3rd row there. So, actually that was the 2nd row. They must be related to the 2nd row here. We are 1-for-1 matchup with the most abundant ingredients in the universe. Of these, carbon is the most chemically fertile element in the entire periodic table. You can make more kinds of molecules with carbon than all other molecules combined. So, if you were going to experiment through the forces of nature with complex chemistry, and you had to pick an element to base it on, carbon is your man. Or your woman, however that goes. Okay, so what I'm saying is, given what carbon is capable of doing, perhaps we shouldn't be so surprised that there's life, because we are carbon-based life. We're just another one of the things carbon has rolled up its sleeve.
maybe life is inevitable, given the abundance of carbon and oxygen and nitrogen and hydrogen in the universe. Try to invert that view. Otherwise, you're left thinking, hey, we're special. You know I would give you right to say you're special? If life on Earth were made of an isotope of bismuth. That stuff is nowhere in the cosmos, and then we're made of it, we're special. Okay? But if we're the most common ingredients of the matter that we know and love, you don't have an argument.
One of the things we know from research in psychology, as well as just practical matters in the conducting of scientific experiments, is that one of the lowest forms of evidence you could possibly invoke is eyewitness testimony. Which is odd because it's one of the highest forms of evidence in the court of law, which disturbs me greatly. Mm-hmm. So if you come from a lab to a science conference and say, this is true, we say, how do you know this? Because I saw it. Well, that's really the end of your talk. And you just leave. And then we say, come back when you have a chart recorder, or you have to just give me something that does not have to flow through your senses. Because your senses is some of the worst data-taking devices that exist. And science did not achieve maturity, modern science did not achieve maturity until we had instruments that either extended our senses or replaced them. And Galileo, it's not an accident that we have modern science as I've described it, experiment, verification, these tactics, these methods and tools, began with Galileo and Francis Bacon, and Galileo was around 1600. That was the invention in that period of the microscope and the telescope. So it's not an accident that all this sort of came together at that time.
I have a couple of words to say about that. Up until early 20th century, philosophers had material contributions to make to the physical sciences. Pretty much after quantum mechanics, remember the philosopher is the would-be scientist but without a laboratory, right? And so what happens is the 1920s come in, we learn about the expanding universe in the same decade as we learn about quantum physics, each of which falls so far out of what you can deduce from your armchair that the whole community of philosophers that previously had added materially to the thinking of the physical scientists were rendered essentially obsolete at that point. And I've yet to see a contribution. This will get me in trouble with all manner of philosophers, but call me later and correct me if you think if I missed somebody here. But philosophy has basically parted ways from the frontier of the physical sciences. When there was a day when they were one and the same. Isaac Newton was a natural philosopher. The word physicist didn't even exist in any important way back then. So I'm disappointed because there's a lot of brain power there that might have otherwise contributed mightily, but today simply does not. Philosophy has it's not that there can't be other philosophical subjects. There's religious philosophy and ethical philosophy and political philosophy, plenty of stuff for the philosopher to do, but the frontier of the physical sciences does not appear to be among them.